There's one muscle in your body that works harder than any other, a relentless engine that literally keeps everything running. So today, we're going to take a closer look at this incredible pump, the heart, and break down how it all works, from its basic layout to the amazing electrical system that powers every single beat.
So, first things first, let's get our bearings. Where exactly is your heart? A lot of people think it's way over on the left side, but that's not quite right. It's actually tucked right in the center of your chest, in a little space between your lungs, and it just tips slightly to the left. And of course, it's all safely protected behind your rib cage.
And how big are we talking?
Well, it's actually pretty simple. Go ahead and make a fist. Yep, that's about the size of it. It's a really easy way to picture the powerful little muscle that's working for you every single second of every single day.
Now, get ready for this number, because it is just mind-blowing. 100,000. That is roughly how many times your heart beats in a single day. Think about that. Every minute, it's pumping about 5 quarts of blood through your whole body. That adds up to over 35 million beats a year. It's just incredible. So how on earth does it pull all of that off? Well, the secret is all in the design. At its core, the heart is a super sophisticated 4-chambered pump that's actually running 2 completely different circuits at the very same time. Let's break that design down. A thick wall of muscle called the septum splits the heart right down the middle, creating a left side and a right side. And each side has a very different job. The right side, it's the low-pressure system. It takes in all the used oxygen-poor blood from the body and sends it on a quick trip over to the lungs. But the left side, wow, that's the high-pressure powerhouse. It takes that fresh, oxygen-rich blood and has the massive job of pumping it out to your entire body. All right, let's trace the path of a single drop of blood, starting with that first loop, the super important detour to the lungs. This is what's known as the pulmonary circuit. So here's what happens on that first little trip. The oxygen-poor blood comes back from its journey around the body and enters the top right chamber, the right atrium. From there, it drops down into the chamber below it, the right ventricle. Then, with a good squeeze, that ventricle pumps the blood straight to the lungs to get a fresh tank of oxygen. But wait a second. With all this pumping and squeezing going on, what stops the blood from just sloshing backward? How does everything keep moving in one single direction? Well, the answer is actually pretty ingenious. Valves. The heart has 4 of them, and they work like perfect one-way gates. You've got the tricuspid, pulmonary, mitral, and aortic valves. Each one opens up to let blood pass through, and then it snaps shut to make sure none of it flows backward. It's a perfectly timed sequence that happens with every single heartbeat. Okay, so our blood is now fresh and full of oxygen. It heads back to the heart, ready for the main event, powering the entire body. This is the second loop, called the systemic circuit. And this is where the real power comes in. The left ventricle, that's the bottom left chamber, has to be the strongest part of the whole heart. Its walls are way thicker and more muscular. And for a good reason. It has to generate enough force to push blood from the top of your head all the way down to the tips of your toes. So let's follow that second loop. That fresh, oxygen-rich blood flows from the lungs into the top left chamber, the left atrium. From there, it drops into that supramuscular left ventricle. Then, with an incredibly powerful contraction, it sends that blood rocketing into the aorta, the body's main highway, which then branches out to deliver oxygen everywhere it's needed. Okay, so we've talked about the plumbing, the chambers, the pipes, but what about the power source? Let's look at the amazing hidden electrical system that tells the heart muscle when to pump. Yeah, exactly. I mean, this muscle doesn't just pump randomly. It has this constant, perfect rhythm, so something has to be telling it exactly when to beat. But where does that signal come from? It turns out the heart has its very own built-in electrical grid. It's called the conduction system, and it's made of these special cells that carry electrical signals through the heart muscle, making sure every single beat is perfectly coordinated and efficient. It all kicks off at a tiny spot called the sinoatrial node, or SA node for short. You can think of it as the heart's natural pacemaker. It's located up in the right atrium, and it fires off the initial spark that starts the whole process, telling the upper chambers to contract first. From there, that electrical spark travels to the atrioventricular node, or AV node. Now, this part is absolutely crucial. The AV node acts like an electrical doorway, and it purposely slows the signal down for just a fraction of a second. Why? That tiny pause gives the ventricles just enough time to fill up completely with blood before they get the signal to pump. It's all about perfect timing.
So, when you step back and you look at the whole picture, the two-part pump, the one-way valves, the perfectly timed electrical system, what you have is, without a doubt, our body's hardest working muscle. And this really just boils it all down, right? The Mayo Clinic says it perfectly. The continuous exchange of oxygen-rich blood with oxygen-poor blood is what keeps you alive. That perfectly choreographed dance happening inside you right now is life itself. You know, this engine, it runs 24/7, from before you were even born until your very last moment. It never, ever asks for a break. Which kind of makes you think, doesn't it? What are you doing to fuel yours?